Okay, let's figure out the open intervals for this function where it's increasing, decreasing, and all that kind of good stuff. So the first thing that I see is there's two pieces here, meaning this is going to be the product rule. So to figure out where it's increasing, decreasing, of course, is the derivative. So the first derivative, I can just leave the 30 outside, bring the 1/3 down, and remember here you're subtracting 1. So that's going to be 1/3 minus 3/3. How I get negative 2/3. Leave the second term alone, again product rule, plus leave the first term alone, and then take the derivative of x, which is 1, and then 9, of course, which is 0. Okay, so let's just kind of make things look a little better. I can make this equal to 10x to the negative 2/3, x plus 9, and then of course plus 30, x to the 1/3. I can distribute here, and hopefully you kind of sort of remember when you multiply with the same bases, you add the exponents. Well, that's like x to the first power, which is the same as 3/3. And then plus 90x to the negative 2/3. I just multiplied 10x to the negative 2/3 times 9. And then plus, just bringing that piece down, 30x to the 1/3. Don't we love all these fractions? And so that's going to give me 10x to the 1/3 plus 90x to the negative 2/3. And then bring that piece down, pass it around. And I see these have the same powers. So I'm going to get equals 40x to the 1/3 plus 90x to the negative 2/3. Now, what I do to look for increasing, decreasing, there's two ways. You can either now do your wonderful number line, right? I don't do it that way, because if I see, oh, I could find the second derivative is not so bad. So remember, this was the first derivative. The second derivative is still going to be power rule, so why not take the second derivative? So the second derivative, bring the 1/3 down, where I'm going to get 40/3, x to the 1/3 minus 1, which is where I'm getting that. And then here, bringing this down would be negative 180/3, x to the negative 5/3, right? Subtract 1, so negative 2/3 minus 3/3. And from here, if I set this equal to 0, because I'm going to look for concavity, I actually can do a little bit of factoring, and this is why I left things over 3, because you might say, well, the 180/3 is 60, but you're going to see I can factor out a 20/3, x to the negative 5/3, and what that leaves me left with is 2x minus 9. Take a minute to take that in. Woo! That's pretty rough, right? But if you distribute back, you'll see how I get these values. What's nice is this piece right here can never ever equal 0. If you don't believe that, kind of come over here to the side. And so this is really 20/3 x to the positive 5/3. How is that going to equal 0, right? Because you can multiply both sides by the variable and poof, it's gone. So the only piece you care about is that piece right there. When does it equal 0? Well, I believe that would equal 0. 2x minus 9 equals 0. 2x equals 9 would be when x equals 9/2. So from here, I can figure out my concavity, which will also tell me where it's increasing, decreasing. And so if I look at from my 9/2, and then because I have to worry about, I can't divide by 0, and I just simply plug values into the second derivative. The second derivative gives me concavity. I don't know, how about -1? How about 1? And how about 5? So I'm just plugging in values into the second derivative because that will tell me the shape of this. So if I go back to the second derivative, and I can even plug it in this piece right here, -1, -5/3, and then 2 times -1 minus 9. In other words, I'm looking at that piece right there. I don't really care what this value is. All I care is that it's positive. So that piece would be concave up. And then I do the same thing with these others. And I will see this is negative, concave down. And then I will see this is positive, so concave up. Meaning on my intervals here, let's write this in another color so you can see it. Meaning my intervals are from -infinity to 0. And then of course, I didn't do that. Then of course, union 9/2 to infinity is going to be concave up. And then from 0, this piece right here, from 0 to 9/2 is going to be concave down. Little messy, but again, you could use the first derivative test to see where it's increasing and decreasing, but works the same way.